To determine the appropriate fuse size for a rooftop unit, several calculations and code considerations are necessary. The first step is calculating the volt-ampere, or volt-amps, rating of the unit. You calculate the volt-amps rating by multiplying the voltage by the amperage. In this case, given a 208 volts, three-phase unit with 23.9 amps, the calculation is 208 volts times 23.9 amps, which equals 5067.2 volt-amps. The next step involves determining the fuse factor. The fuse factor is a multiplier used to determine the appropriate fuse size based on the volt-amps rating. Fuse factors can vary depending on the type of fuse and the specific application. For general-purpose fuses, a fuse factor of 1.25 is commonly applied. To calculate the fuse size, multiply the volt-amps rating by the fuse factor. Using the previous results, the calculation is 5067.2 volt-amps times 1.25, which equals 6334 volt-amps. To determine the amperage rating of the fuse, divide the fuse size in volt-amps by the voltage. This calculation is 6334 volt-amps divided by 208 volts, which equals approximately 30.45 amps. Considering relevant codes, NEC section 430.32. C states that fuses shall be selected to have an ampacity not less than 125% of the full load current of the motor. NEC table 430.152 provides recommended fuse sizes for various motor current ratings. Based on these calculations, a 30 amp fuse could be appropriate for the rooftop unit. However, it is always essential to consult with a licensed electrician to confirm the correct fuse size and to verify compliance with all applicable codes and local regulations. This is because factors such as ambient temperature, specific fuse characteristics, and the presence of other loads on the circuit can influence the selection of the most suitable fuse. Firstly, consider the specific type of fuse being used. Different types of fuses, such as time delay fuses or fast-acting fuses, have varying characteristics that can affect their suitability for a particular application. Time delay fuses, for example, can withstand temporary overloads without tripping, which may be beneficial for motors that experience inrush currents during startup. Secondly, it's important to review the rooftop unit specifications and nameplate data carefully. The manufacturer's recommendations for fuse size should be followed, as these recommendations are based on the unit's specific electrical characteristics and operating conditions. Thirdly, consider the ambient temperature in which the rooftop unit is operating. High ambient temperatures can affect the current carrying capacity of fuses, potentially requiring a larger fuse size to ensure proper protection. Fourthly, assess the presence of any other loads on the same electrical circuit. If the rooftop unit shares a circuit with the other equipment, the fuse size must be adequate to protect all of the loads on the circuit, not just the rooftop unit itself. Fifthly, remember that oversizing fuses can be dangerous and is not recommended. Oversizing a fuse can lead to inadequate protection of the equipment and wiring, increasing the risk of electrical fires or other hazards. Sixthly, undersizing fuses can lead to nuisance tripping. Undersizing a fuse, on the other hand, can cause the fuse to trip frequently, interrupting power to the rooftop unit and potentially causing damage to the equipment. Seventhly, understand the difference between minimum circuit ampacity and maximum overcurrent protection. Minimum circuit ampacity refers to the minimum size conductor required for the circuit, while maximum overcurrent protection refers to the maximum size fuse or circuit breaker allowed. The fuse size should not exceed the maximum overcurrent protection rating for the circuit. Eighthly, consider voltage drop. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of conductors. The fuse size should be selected to minimize voltage drop and ensure that the equipment receives adequate voltage. Ninthly, document all calculations and decisions related to fuse size selection. This documentation can be helpful for future reference and can also be used to demonstrate compliance with codes and standards. Tenthly, keep up to date with changes to the NEC and other relevant codes and standards. The electrical codes are constantly evolving, and it's important to stay informed of any changes that could affect fuse size selection. The NEC provides guidelines for selecting the appropriate fuse size based on the type of load, conductor size, and other factors. In addition to the NEC, other codes and standards may also apply to fuse size selection depending on the location and type of installation. These may include local building codes, insurance requirements, and industry standards. For example, Underwriters Laboratories or all standards provide requirements for the design, testing, and certification of fuses and other electrical components. It's important to ensure that the fuses used in the rooftop unit are UL listed or certified by another recognized testing laboratory. Furthermore, proper installation and maintenance of fuses are essential for ensuring electrical safety. Fuses should be installed in accordance with the manufacturer's instructions and should be regularly inspected for signs of damage or deterioration. Blown fuses should be replaced with fuses of the same type and rating. It's also important to ensure that the fuse holders are clean and in good condition. In summary, determining the appropriate fuse size for a rooftop unit requires careful consideration of several factors, including the unit's volt amps rating, the fuse factor, applicable codes and standards, and the specific characteristics of the installation. Consulting with a licensed electrician is always recommended to ensure that the fuse size is correct and that the installation complies with all applicable regulations. Remember to prioritize safety and compliance when working with electrical systems. This includes wearing appropriate personal protective equipment, following safe work practices, and ensuring that all electrical work is performed by qualified personnel. It is also beneficial to understand the specific requirements of the local utility company regarding fuse size selection and overcurrent protection. Some utility companies may have additional requirements or recommendations that must be followed. In addition to the calculations and code considerations, it is also helpful to have a basic understanding of how fuses work. A fuse is a safety device that is designed to protect electrical circuits from overcurrents. It consists of a thin strip of metal that is designed to melt and break the circuit if the current exceeds a certain level. The fuse is typically enclosed in a non-combustible housing to prevent fire or other hazards. When selecting a fuse, it is important to choose one that is rated for the appropriate voltage and current. The voltage rating of the fuse should be equal to or greater than the voltage of the circuit it is protecting. The current rating of the fuse should be slightly higher than the normal operating current of the circuit, but not so high that it allows excessive current to flow in the event of a fault. Fuses are available in a variety of types, including cartridge fuses, plug fuses, and blade fuses. Each type of fuse has its own advantages and disadvantages, and the best type of fuse for a particular application will depend on the specific requirements of the circuit. Cartridge fuses are typically used for higher current applications, while plug fuses are typically used for lower current applications. Blade fuses are commonly used in automotive applications. When replacing a blown fuse, it is important to use a fuse of the same type and rating. Using a fuse with a higher rating can be dangerous, as it may not protect the circuit from overcurrents. Using a fuse with a lower rating can cause the fuse to blow frequently, which can be inconvenient and may also indicate a problem with the circuit. It is also important to ensure that the fuse holder is clean and in good condition. A corroded or damaged fuse holder can cause the fuse to overheat and fail. In addition to fuses, circuit breakers are also commonly used to protect electrical circuits from overcurrents. Circuit breakers are similar to fuses in that they are designed to interrupt the flow of current in the event of a fault. However, circuit breakers are reusable, while fuses must be replaced after they blow. Circuit breakers are available in a variety of types, including thermal circuit breakers, magnetic circuit breakers, and electronic circuit breakers. Each type of circuit breaker has its own advantages and disadvantages, and the best type of circuit breaker for a particular application will depend on the specific requirements of the circuit. Thermal circuit breakers are typically used for lower current applications, while magnetic circuit breakers are typically used for higher current applications. Electronic circuit breakers offer more advanced features such as adjustable trip settings and remote monitoring capabilities. When selecting a circuit breaker, it is important to choose one that is rated for the appropriate voltage and current. The voltage rating of the circuit breaker should be equal to or greater than the voltage of the circuit it is protecting. The current rating of the circuit breaker should be slightly higher than the normal operating current of the circuit, but not so high that it allows excessive current to flow in the event of a fault. It is also important to consider the interrupting rating of the circuit breaker. The interrupting rating is the maximum amount of current that the circuit breaker can safely interrupt. The interrupting rating should be high enough to handle the maximum fault current that could occur in the circuit. When installing a circuit breaker, it is important to follow the manufacturer's instructions carefully. Circuit breakers should be installed in a panel board or enclosure that is properly grounded. The wiring connections to the circuit breaker should be tight and secure. It is also important to label the circuit breaker clearly so that it can be easily identified. In addition to fuses and circuit breakers, other types of overcurrent protection devices are also available. These include surge suppressors, ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, RFCIs. Surge suppressors are designed to protect electrical equipment from voltage surges, which can be caused by lightning strikes or other electrical disturbances. GFCIs are designed to protect people from electrical shock by detecting ground faults. RFCIs are designed to protect against electrical fires by detecting arc faults. Arc faults are dangerous electrical conditions that can occur when insulation breaks down or connections become loose. RFCIs are required in many new homes and are also recommended for older homes. In summary, overcurrent protection is an essential part of any electrical system. Fuses, circuit breakers, and other overcurrent protection devices are designed to protect electrical circuits from damage and to prevent electrical fires and shocks. When selecting and installing overcurrent protection devices, it is important to follow all applicable codes and standards and to consult with a qualified electrician if you have any questions. Always prioritize safety when working with electrical systems. Remember to turn off the power before working on any electrical circuits and to use appropriate personal protective equipment, such as gloves and safety glasses. It's also crucial to have a clear understanding of electrical safety practices and procedures. This includes knowing how to identify potential hazards, how to use electrical testing equipment, and how to respond to electrical emergencies. Regular electrical safety training is recommended for anyone who works with electrical systems. This training can help you stay up to date on the latest safety practices and procedures and can also help you develop the skills you need to work safely around electricity. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before making any decisions about electrical systems. This ensures that all work is performed safely and in compliance with all applicable codes and regulations. It's also worth noting that the specific requirements for fuse size selection and overcurrent protection can vary depending on the type of equipment being protected. For example, the requirements for protecting a motor may be different from the requirements for protecting a lighting circuit. Therefore, it's important to consult the manufacturer's specifications and any applicable codes or standards to ensure that the correct overcurrent protection is selected. In addition, some electrical systems may require the use of specialized overcurrent protection devices, such as current-limiting fuses or solid-state circuit breakers. These devices offer enhanced protection capabilities and may be necessary in certain applications. Current-limiting fuses are designed to quickly interrupt high fault currents, while solid-state circuit breakers offer more precise and adjustable trip settings. Ultimately, the goal of overcurrent protection is to provide a safe and reliable electrical system. By selecting and installing the correct overcurrent protection devices, you can help prevent electrical fires, protect equipment from damage, and ensure the safety of people who use the electrical system. Remember to prioritize safety and compliance when working with electrical systems, and always consult with a qualified electrician if you have any questions or concerns. Understanding the principles of overcurrent protection is essential for anyone who works with electrical systems. This knowledge can help you make informed decisions about overcurrent protection and can also help you troubleshoot electrical problems. It's also important to stay informed about changes in electrical codes and standards. The electrical codes are constantly evolving, and it's important to stay up to date on the latest requirements. This can help you ensure that your electrical systems are safe and compliant. Consider the altitude where the rooftop unit is installed. At higher altitudes, the air is less dense, which can affect the cooling capacity of the rooftop unit and the performance of the electrical components. It may be necessary to adjust the fuse size or other electrical parameters to compensate for the effects of altitude. Consult the manufacturer's specifications for guidance on altitude directing. In conclusion, determining the correct fuse size for a rooftop unit is a multifaceted process. It involves careful calculations, adherence to electrical codes, consideration of environmental factors, and a thorough understanding of electrical safety principles. While online resources and general guidelines can provide a starting point, consulting with a licensed electrician is crucial for ensuring a safe and compliant installation. A qualified electrician can assess the specific requirements of the rooftop unit and the electrical system, taking into account all relevant factors to select the appropriate fuse size and ensure proper overcurrent protection. This collaborative approach guarantees that the electrical system operates safely and efficiently, protecting both the equipment and the individuals who interact with it.